In our last video, we saw a calculation formula for a directional derivative that involved the partials of the function f of xy written down as a vector. And it turns out that vector is so important it has a name. If z equals f of xy is a function, then the gradient vector of f is that vector we defined, whose I component is the partial with respect to x, and the j component is the partial with respect to y, or written down in our bracket notation fx comma fy, and we could swap the notations around however we wanted. So we denote the gradient vector with this upside down triangle. It looks like the change in f, but we flip that upside down. We actually read this del f, or the gradient of f, and you can say it either way. When I want to evaluate a gradient at a point, I can either write it down like this or like this. But that lets me write down my directional derivative formula a little more simply. The derivative of f in the direction of u at p naught is del f of x naught y naught dot the vector u. And remember, u is a unit vector in the direction of motion, and p naught is the point x naught y naught I'm evaluating my derivative at. Let's do an example so we can practice using the gradient notation. So here I have f of x comma y equals x cubed minus 9xy plus y cubed. I'm supposed to take the derivative at the point 2 comma 1, moving in the direction of the vector 1 comma root 3. Well, first up, let's go on and make this a unit vector. So that vector has magnitude 2. So the vector u I'm looking for is 1/2 comma root 3 over 2. And if I thought about my unit circle, I probably could have skipped all of that work. The vector del f is the vector made of the partial with respect to x. So let's see, 3x squared minus 9y, comma, the partial with respect to y, minus 9x plus 3y squared. To compute my directional derivative, I need to evaluate my gradient vector at the point 2 comma 1. Well, let's see. Plugging in a 2 for x, that's going to be 4 times 3 is 12 minus 9, 3 in the I component. And in the j component, let's see, that's going to be minus 18 plus 3 is minus 15. So there's my gradient vector, and I'm ready to calculate my directional derivative. In the direction of u from the point p naught, and I need to take a dot product of 3 minus 15 with 1/2 comma root 3 over 2. So let's see, that's 3 over 2 minus 15 root 3 over 2. Not a very pretty answer, but that is it. 3 minus root 15, roots of 3 all over 2, not 3. And there's my answer.